We're starting chapter 12 now, which means we're done with the preliminary stuff that chapter 11 covered. Now we're going to start solving for what are called linear equations. What do you think linear equations are? If you had to define the word linear equation, what would that mean?
Something related to X and Y.
Equation that defines a line. Has two variables, X and Y. That's a linear equation. More so, there are no exponents or any special operations. By special operations, I mean no square roots, no absolute values, no any of that stuff.
It doesn't show it.
That might be necessary. There. There. So linear equations. The equations that define a line has two variables, X and Y, no special operations. It looks like this. That's a linear equation where A, B, and C are numbers. A, B, and C could be integers, fractions, or a combination, or decimals. So in this chapter, we're going to start learning how to solve equations. When we say solve, what does that mean? Find the value of the variable that makes the equation true. That's called a solution. When we solve linear equations or any type of equations, we're looking for a solution. It's what value or values makes the statement true or the equation true. So a solution set are all solutions possible. And then we have equivalent equations. What do you think equivalent equations are? What would make two equations equivalent? For example, are these two equivalent? Yes, they are. If we solved both of those, we get the same answers. So equivalent equations are equations that have the exact same solution sets. How do we know those two equations are equal? If we divided both of these numbers here by 4, what do we get? If we divided both of these by 4, what do we get? So we get 4x over 4, 8 over 4. What is 4x over 4? The 4's cancel, so we have x. 8 divided by 4 is? Yeah, because 4 goes on 8 twice. So this side equals x plus 2. This side equals x plus 2. They're the exact same equations. They just look different. But they have the exact same solution sets. The solution set there. So those are the terms we have to know. The concept we have to know. Let's look at the additive property of equality. The additive property of equality. Here's what it says. It's pretty straightforward. We're going to look at A, B, and C are, right now, let's do whole numbers. But they could be anything. We're going to say they're real numbers. A, B, and C are real numbers. If you want to say real, that's a bigger set. If A equals B, if A equals B, remember, this is called the additive property of equality. If we add the same number to both sides, they're still going to be equal. It helps if you look at the equal sign as a balance beam. If A is here and B is here, if I add a C here, I better add a C to that side to keep the balanced equation. That's all it tells us to do. In other words, it goes with the golden rule. Whatever you do to one side, you have to do exactly the same thing to the other side. Does it work with subtraction? Yes. If A equals B, then A plus a negative C equals B plus a negative C. Because if the top one's true, the next one has to be true. Okay, we have two signs next to each other. What do they become? You can only have one sign between them. Right. So it becomes A minus C equals B minus C. So the same thing. I can, if I add a number to A, I have to add it to B. If I subtract it from A, I have to subtract it from C. Some time ago, we talked about the properties of math. The inverse property of addition. The inverse property of addition says this. If I have a number, what can I add to it to make it 0? Mhm. So if I had 3, if I add a negative 3 to it, it would give me 0. Because again, we have two signs, so it's x minus x equals 0. 3 minus 3 equals 0. True. As long as those are true, we can solve linear equations. Using the additive property of equality and the inverse property of addition, we can solve linear equations. When we say solve, we mean get X by itself. When we say solve, we're saying get the variable by itself. All right. Let's do some examples here using these two properties. Here's some examples. X minus 8 equals 13. Our goal to get X by itself. So to get X by itself, what do you have to do? Step 1. Remove all non-X's from the X side. So we'll get X by itself. So what do we have to get rid of? No. No. Negative 8. That negative belongs to that 8. So how do we get rid of negative 8? Turn it into positive. So we add 8 to both sides. So X negative 8 plus 8, 8's cancel. 13 plus 8 is 21. And then always check your answer. I'm just going to private CYA. Plug your solution into the original equation. And see if it's true. To check your answer, plug the solution into the original equation. So the original equation was X minus 8 equals 13. You're saying that X is 21. Minus 8 is 13. So that's a good solution. Let's look at another one. X minus 3.7 equals negative 8.1. So we have to get x by itself. So we have to do what? We have to get rid of the negative 3.7. How? Since it's negative, we have to do the opposite, which is add 3.7 to both sides. So negative 3.7 plus 3.7, they cancel. So we have x by itself. Since the other side, 8.1 is negative and 3.7 is positive, what do? How do we do this part? Is the answer to be positive or negative? Why? Because 8.1 is bigger, the answer is going to be negative. True. Take the sign of, if the signs are different, take the sign of the larger and then subtract the numbers. 8.7 minus 8.1, I'm sorry, 8.1 minus 3.7. We can't do that. 1 minus 7, you can't do it. So you got to borrow 1, which makes it 11. 11 minus 7 is 4. 7 minus 3 is 4. So the answer is negative 4.4. Check your answer. X minus 3.7 equals minus 8.1. Anywhere I see an X, I put a negative 4.4. So this is why we've been doing all that stuff before this. They're both negative, so the answer is negative. 4.4 plus 3.7, so now we add the two numbers. 4 plus 7 is 11. 4 plus 3 is 7, plus 1 is 8. So it's negative 8.1 is the same thing as negative 8.1, so it's a good answer. There's another way you could do this. I'll show you another way. The second way to solve equations with decimals. X minus 3.7 equals minus 8.1. This way is get rid of the decimals by multiplying each term by a factor of 10. So we get rid of the decimals. How many spaces do we have to move? What's the most spaces we have to move to remove decimals? Yeah, so it's only one. Both of these are only one step. So what do we have to multiply to move the decimal place over one? What do we multiply by? Yeah. So if I had the number 0.02, I would multiply by 100. Each decimal place is a 10. 0.02 times 100 is 2. 0.0002, 1, 2, 3, 4 times 10,000 equals 2. So since I only have to move one space, that's 10. So I multiply each term by 10. Here's a term, here's a term, and here's a term. A term, remember, is anything separated by a plus, minus, or equals. So I have 10x minus 10 times 3.7 is what? 37. 10 times 8.1, negative 81. So now those decimals are all gone. Does it look a little bit easier or less problem? What do we do next? Get rid of the non-x. So we have to get rid of this negative 37. How? By adding 37 to both sides. So we're left with 10x. Again, same thing. On the right-hand side, you have positive and negative. Since 81 is bigger, the answer is going to be negative. 81 minus 37. Borrow 1. So it's negative 44. And to get the x by itself, we have to get rid of this 10. How do we get rid of the 10? Yeah, because how is 10 connected to x? It's multiplied. What's the opposite of multiplication? Division. Since we divided it by 10, we move the space over 1, the decimal over 1. So it's 4.4. And there you have it. So I give you the same answer. It's just a lot of times it's much easier if we get rid of the decimals and work it out and then put the decimals at the end. Same thing with fractions. We get rid of the fractions. If the answer is going to be a fraction, it'll be there at the end. Let's do another example. X minus 4.1 equals 6.3. Use either method you want to, you get the same answer. So to get x by itself, we have to get rid of the negative 4.1. The opposite of negative 4.1 is positive 4.1. So we add 4.1 to both sides. Those cancel. So we have x. 3 plus 1 is 4. This is the decimal. 6 plus 4 is 10. Whenever you add decimals, you have to line up the decimals. With, yes. Yeah, that's the way I prefer, but you can do whatever method you want to. If you do the tens, you get 10x minus 41 equals 63. Add 41 to both sides. 10x equals 104 divided by 10 equals 10.4. And it doesn't matter which side of the equation the variable's on or what the variable is. Let's look at these two. On the left one, we want to get that's the variable, but to get it by itself. So we have to get rid of what? None of the plus 2. How do you get rid of plus 2? Minus 2. So those cancel. Negative 3 minus 2, they're both negative. 3 plus 2 is 5. So the answer is negative 5. Check your answer. Negative 3 equals a plus 2. Put this in place of a. So negative 3. 5 and 2, 5 is bigger, so it's negative. 5 minus 2 is 3. So it's a good answer. So that's the answer. Again, the variables are, so we have to get rid of negative 16 by adding 16 to both sides. So this is both positive. 38 equals R. R equals 38. Check your answer. 22 equals negative 16 plus R. In place of R, I put 38. Is bigger than 16, so the answer is positive. 38 minus 16. 8 minus 6 is 2. 3 minus 1 is 2. The answer is 22. So it's a good answer. What if we have variables on both sides? If you have variables on both sides, bless you. If you have variables on both sides, always move the smaller variable to the larger variable. Can anybody guess why? Why do you always move the smaller to the larger? So the coefficient remains positive. So the coefficient in front of the variable remains positive. If you move it the other way, you'll get a negative coefficient. And we'll look at that in a second. So in this equation, which one do I move? The 3K. How? So it's minus 3K. Both sides. 3Ks cancel, so I have 15. 8 minus 3 is 5. You get the K by itself, what do? Yes, since it's 5 times K, I have to do the opposite. So I divide both sides by 5. So K is equal to 15 divided by 5 is 3. And then CYA. Check your answer. Anywhere I see a K, I put a 3. Anywhere I see a K, I put a 3. 3 times 3 is 9. Plus 15. 8 times 3 is 24. 15 plus 9 is 24. So that means this is your answer. Makes sense? Does it look pretty easy? Okay, let's see if you didn't do what I just said. What if you move the larger to the smaller? Remember, I tell you, always move the smaller to the larger. If you don't do that, let's move this bigger to the smaller. Let's say you want K's on the left side. What if we subtract 8K from both sides? Well, yeah. So here on the right-hand side, 8 minus 8 is 0. 3 minus 8. 8's bigger, so it's negative. 8 minus 3 is 5. Plus 15. Well, no. It's gonna give you the same answer, but you have more work to do. What would you solve now? What would you do now? You're solving for K. What do? Here's the K. So you have to look at this side. What do you want to get rid of next? 15. How? Because that's a 15. It's a plus, so I have to minus. I subtract 15 from both sides. I have to subtract 15 from both sides. So I got negative 5K equals negative 15. If at the last step, X has a negative sign, then change all of the signs on both sides of the equal sign. Notice there's no more plus or minus on the left-hand side where the variable is. There's a negative though. Treat the signs and the numbers separately. I know most of y'all say, let's divide by -5. Yes, you can do that, but the most common mistakes occur when you deal with too many negative signs. So here, to save you chance of making a mistake, let's just change the signs. Let's change that to positive, change that to positive. So we have 5K equals 15. Across the entire board, change all the signs. Let's say we had something like this. I'm solving for X. I change all of the signs. Because I want to have whatever the variable I'm looking for, I want it to be positive. So I change all the signs across the board. And then to get the variable by itself, I do what? How do I get the K by itself? Divide both sides by 5, by the coefficient. Whatever's in front of the variable, divide by it. 15 divided by 5 is 3. It's the same answer we just got earlier. There. Negative 5x plus 3 equals negative 15x minus 2. Okay, we have x's on both sides. Which one do we move? Which one? Which one are we supposed to move? The smaller, right? Which is smaller, -5 or -15? Let me ask you again. Which one's farther to the left on the number line? -5 or -15? -15 is smaller. Whatever is farther to the left is smaller. -15 is smaller than -5. You would know that because if you move -5 over, your x would still be negative. And we don't want that. So we would move 15 over. So we add 15x to both sides. (15 minus 5) is going to be a positive 10. X plus 3 equals -2. Then we have to get rid of the 3. It's positive 3. We subtract 3 from both sides. Get rid of pluses, minuses first. We have 10x. They're both negative. 3 plus 2 is 5. And then we do what? To get rid of the 10, we divide both sides by 10. So what's my final answer? Yeah. It has a 2 in it, yes. Well, it's closer. It has a negative. Has to have a negative because the negative's right there. The answer has to be negative. Simplify. On top, we have 5. What is 10 made up of? 2 times 5, right? These cancel. Where's the 2? It's on the bottom. It stays on the bottom. What's on top? A 1. So it's -1 over 2. All right, let's look at how we would check that answer. The original question was -5x plus 3 equals -15x minus 2. And we're saying the answer is x equals -1/2. So we have -5, -1/2 plus 3, -15 times -1/2 minus 2. So we could simplify just a little bit. Negative times negative is a positive. So 5 over 1 times 1 over 2. 5, since nothing cancels, 5 times 1 is 5 over 2 plus 3. Same thing on the other side. Negative and negative is a positive. Nothing cancels, so 15 times 1 is 15. 1 times 2 is 2. Okay, now, let me show you what you're going to be using whenever you have an equal sign and fractions. If you have an equal sign in fractions, if you have an equal sign in fractions, get rid of the fractions. If you have an equal sign in fractions, get rid of it. This is how you get rid of the fractions. It's 5 steps. Well, at the most 5 steps. 1, find the LCD. What is the LCD? What does it mean? What is it in this case? What's the least common denominator of our equation? On both sides of the equal sign.
15.
Denominator is the bottom number. Yeah, it's the only one we have. It's 2. So first off, find the LCD. In our case, it's 2. Next step, multiply the LCD to each term. Multiply the LCD to each term. Remember, a term is anything separated by plus, minus, or equals. So we have 4 terms. We multiply the LCD, which is 2. So we have 2 times 5 over 2 plus 2 times 3 equals 2 times 15 over 2 minus 2 times 2. So we multiplied each of these terms by 2. So far, so good. First step, find the LCD. Second step, multiply the LCD, put it in front of each term. Third step, don't multiply just yet. Now, whenever you have fractions, reduce. Cancel what you can. Can anything cancel across the board here? Remember, this one is 2 over 1, and that's 2 over 1. Can anything cancel in this first part? The 2's. There's no denominator there. Same thing with the other one. The 2's will cancel. So there's a 1 there. 2 goes into 2 1 time. So we have 1 times 5, 2 times 3, 1 times 15, minus 2 times 2. Now multiply to get rid of, to remove parentheses. So 1 times 5 is 5. 2 times 3 is 6. 1 times 15 is 15. Minus 2 times 2 is 4. Then solve. 5 plus 6 is 11. 15 minus 4 is 11. There, it works. So x equals -1/2 is our solution. Is this process pretty straightforward? Did everybody follow that? Because you'll be faced with a lot of fractions and equal signs in your math career. So this will make it much easier. I'll show you. Let's do an example of just fractions. Okay, there are fractions and there's an equal sign. What do we do? No, read the last page I put on the board. What's the first step? Find the LCD. What's the LCD? 6. The smallest number that all of these fit into is 6. So that's the LCD. That's the first step. Second step, what do you do with the LCD? Multiply the LCD. You have notes. Don't wait to put it on the board. You have notes. Refer to those. The second step you just copied from the board, hopefully, is multiply LCD to each term. So we have 6 times 2 times 3x plus 6 times 1/6 equals 6 times x minus 6 times 5/6. What's the third step? Reduce. Very good. So the 3, because the whole purpose is this process gets rid of the fractions. The 3 goes into 6 how many times? 2. The 6 goes into 6 once. The 6 goes into 6 once. So this is what we have left. Which one of these two equations are easier to look at and solve? The bottom one. They're exactly the same. It's just that we got rid of the fractions. Once you get rid of the fractions, then it's much easier. So step 4 is what? Multiply to get rid of the parentheses. 2 times 2 is 4. X. 1 times 1 is 1. 6 times x is 6x. 1 times 5 is 5. Now, last step is solve. Again, whenever I put anything on the right-hand side of the page, that's important. That's stuff you have to write down. Because those are the procedures, those are the steps. Okay, now how do you solve this? What do you do next? What's that? Minus 4x. Move the smaller x to the larger x. So minus 4x. Six minus 4 is 2. Then what? You have to get rid of the non-x. So we add 5 to both sides. One plus 5 is 6 equals 2x. One more step. What's the last step? Yeah, divide both sides by 2. So x is equal to 3. And you check your answer. What do y'all think? Kind of, sort of? Let's look at number 63. Let's just jump in the deep, or let's do number 62 first. Let's jump in the middle of the pool. Two times negative 3r plus 2 equals negative 5r minus 3. Well, we're running out of time. What do you think you have to do first? Beautiful. Yes. I have to get rid of it. Since I can't do anything inside the parentheses, I have to get rid of the parentheses by the distributive property. Excellent. Remember the name of it. Good job. So how do we do that? Positive times negative is negative. 2 times 3 is 6r. Positive times positive is positive. 2 times 2 is 4. That's it for that one. Negative times positive is negative. 5 times r is 5r. Negative times negative is positive. 5 times 3 is 15. So far, so good. It's just distributivity. Again, do the signs and the numbers separately. We have x's on both sides. Which one do we move? R's. I usually write R's, but they like x's for some reason. R's. X. So which one do we move? Which R do we move? The negative 6. Very good. Because it's smaller than negative 5. So we add 6r to both sides. Six minus 5 is 1, so it's r. Plus 15. Then subtract 15 from both sides, get r by itself. Fifteen's bigger than 4, so it's negative. 15 minus 4 is 11. There's your answer. And you would do the CYA. And it would work. Which, what we've done also during these examples, we've talked about the multiplicative property of equality. This is the next section. Or, I'm sorry, 12.2. This is the next section. We've been doing it all along. It says if A equals B, then if I multiply a number to A and the same number to B, they're going to be equal. When have we used this property? We did it here. How do we get X by itself? Divided by 3. What you're really doing is multiplying by the reciprocal of this. That's what this rule is telling you. So it's really dividing by it. So X equals 5. So we've done both of those properties. And next class, we'll spend a lot of time doing some more examples. And then we'll move on to the other properties. Okay? What do you think about today's stuff? Not getting as lost as used to be? The fractions, yes. And that's why I'm showing you, we're gonna do a lot of fractions. The way I showed you here, it'll make your life much easier for you. Get rid of the fractions and it'll be much easier for you. Okay, everybody. Have a great weekend. This is the end of this week.